Hey there, and welcome back. Hope you had some fun while we were apart. Given that now it's time to get back to work and finish up DDL, Data Definition Language. In particular, it's my experience that once you've worked on a design for a while, invariably you discover that there are some modifications you'd like to make to that design. Your original thoughts just weren't complete, and you've had a chance to stew on those ideas for a while, and now you'd like to go in and make some modifications. Well, that's exactly what we're going to do within this particular lecture. In particular, we're going to learn some more about the alter command, how we can make some modifications to our tables, how to truncate tables, and then finally how to test our triggers to make sure they are performing in a fashion that similar to what we had expected. Should be great fun. Hang on, let's take a ride together. Okay, gang, the code that we're going to be examining in this particular lecture is available as a resource file associated with this lecture. So if you want to pause right now, please go ahead and download the file entitled mystoremodifications.txt. Go ahead and open that guy in WordPad or some equivalent text editor. Don't worry about renaming them or moving them around. We're just going to cut and paste from that guy into Developer. And so go ahead, pause, download that guy, and then log into Developer as MyStore if you want to follow along. Great, let's begin. If you'll recall, before we created the MyStore user, we dropped that user with a cascade to ensure that we were starting out with a clean slate. Well, we're going to do the same sort of thing here before we start inserting data. We're going to ensure that all our tables are empty by truncating each of them. But before we go too far, let's give a quick note on the difference between delete and truncate. We'll discuss delete command in our next section when we cover DML, or data manipulation. But for now, what you need to know is that when you delete rows from a table, all the constraints are checked for every row deleted. In addition, a copy of all the work is kept in memory just in case you decide to roll back your transaction, thus recovering those otherwise deleted records. Net deletes can be very slow when performed on a large number of records. As such, if at all possible, big record set deletions should always be avoided. What's the alternative? Truncate. Truncate says just check once at the table level for constraints. If constraints exist which may invalidate data, go ahead and stop. Oracle's not going to let you hurt yourself. However, if there are no constraints, just go ahead and blow away all the records without regard to rollback and or constraints. Net truncate is super fast, but pretty dangerous as well. Only use truncate when you're sure it's a good idea. Remember, you cannot roll back a truncate. Now for us here, truncate's really the perfect solution because we want to completely clean out everything in our database and start with a clean slate. All right, given that little background, let's copy the first set of commands at the top of the script into Developer and then discuss. It says alter table countries, disable constraint countries PK cascade. What's that doing? Well, it's turning off or disabling the country's primary key constraint. Then truncate table countries, blow away all the rows in countries, and then alter table countries enable constraint countries PK. In other words, turn that constraint back on. Makes perfect sense, right? First one says go disable the primary key constraint, blow away the records, turn the constraints back on. Straightforward enough. Why did we have to disable the PK constraints? Well, remember, a truncate command first checks the table to see if constraints exist, and if they do, it will not execute the command. How do we get around this? Well, we kind of tricked Oracle into thinking the customer table had no constraints by disabling them before truncation. But then we re-enabled them right after we had completed it, so everything goes back into a clean state. Pretty dangerous, but effective when properly handled. All right, I'm not going to bore you with the rest of these these truncation commands, as they are all variants on this same theme. I suggest you review them to ensure you understand all the nuances. But that, guys, please just go ahead, cut, paste, and then execute all these guys within Developer. Side note, if you need to know what constraints exist on a particular table, you can query the meta tables owned by system. In our particular case, the syntax would be select asterisk from user constraints where table name equals customers. Hey, that was just a little tease for our upcoming lectures on queries. Hang in there, folks. We'll get there in due time. And queries are really the meat of SQL and by far the most interesting component. So it'll be cool. All right, as I mentioned in the intro, by this time in your schema work, you've invariably decided that, you know what, there's a couple of improvements and or modifications that you'd like to make. It's very common practice, particularly when you're dealing with a large schema, possibly hundreds, maybe even thousands of tables. We're going to learn next is how to get in there and make those modifications in a clean and safe fashion. So let's start looking at some more syntax, in this case, DDL alter statement. Here, for example, are a couple of thoughts I had with respect to the customers table. I'm thinking I'm wanting a flag to indicate preferred customers or customers who are regular buyers. Okay, then let's add a column to the customers table called preferred cust, which will be a single one-character field taking a value of either yes or no, y or n, and having a default value of y. Easy enough, and I think it's a pretty good idea. Probably should have thought of it in the first place, but I didn't. Next, I'm thinking we need to allow variable pricing at the time of sale. Grandma's got to get the top value she can for her moonshine, so let's allow for that. Let's go ahead and change the unit price field in the products table to one called suggested price. Notice from this syntax there is no rename option in the alter command. I had to drop the old column and then create a new one with a new name. If I had had data in the old column, I would have done the create first, then updated the new field with the old data, and then dropped the improperly named field. Common practice. Finally, let's finish this update by modifying our order line items table to correspond with the suggested price mentality we just introduced within the products table. First, we drop the extended price column and then create the new sales price field. That is the price at which we actually sold the item. Now let's do something cool. Let's add a virtual column named extended price, created by taking the sum of quantity and sales price. Note, with virtual columns, you don't insert or update the actual field. These fields are simply calculated as required at the time of query. Cool. That looks better, and we learned about the alter command as well as virtual columns at the same time. I'm feeling good. Okay, at this point, if you haven't already made these changes to your schema, go ahead and make them now before we start testing our triggers. Oh yeah, one more thing. When you make these types of off-the-cuff changes, make certain to go back and update your ER diagram accordingly. It's something that I always seem to forget to do, but you just got to work at it. All right now, guys and gals, a word of caution about some of the code you're going to see while we test our triggers in this next section. To test a trigger, you have to do inserts, and that's data manipulation language, and we haven't studied it yet. In addition, we're going to look at some queries. Again, further down the road for us with respect to subsequent sections. Let's not get too excited about it for now. We're just testing our trigger. Absorb what you can out of the syntax, but please know that we'll study it in detail going down the line. So Don't feel like you need to memorize this stuff at this point. We're just testing our triggers at this point. Good enough, thanks. This is an insert statement on the customers table. We will use it to test the before insert trigger on that same table. Check it out. We tell Oracle which table we want to add a record to, give a list of fields to be populated, and then a list of the values to be used to create that record. Straightforward enough. Let's now execute this very simple query on the customers table to see what was actually stored. Look what our trigger did. It changed our assigned customer ID value of -10 to 1. Why 1? Well, remember, that's the first value of our customer ID sequence. Looks like our trigger is operating properly on a single record insert with values. Next test is to try multiple inserts with values and make certain our trigger is still properly working. All right, here we added 2 records at the same time, both specified with a customer ID of -10. Our trigger properly reassigned that value to 2 and 3 respectively. Perfect. Our customer ID value is being properly sequenced via our sequencer. Next, we'll test a single record insert through a select statement. First, we verify that our select statement in fact does generate exactly 1 row of output. Yep, returning a single row. Again, let's not get too excited about the insert syntax at this point. We'll get there in the next section. For now, we're just testing our trigger. All right, now let's go ahead and execute the insert statement and verify the results. Beautiful. All 4 rows are looking perfect. All right, now we have to test our trigger on an insert with a large record set being inserted. Let's begin by verifying that our select statement creates 100 rows, each with the same invalid primary key and corresponding goofy first and last names. All right, looks like it's fine. Now let's go ahead and realize the corresponding insert statement with the select and then verify our results with the select statement. Oh, beautiful. Our trigger is working perfectly. Time to do a commit. Remember, commit tells Oracle, go ahead and make those inserts permanent now. Write them to disk. Hey, you guys want to go through this same exercise? The code is all in your download file. Make certain, however, that you commit before we move forward. Okay, gang, that was a good test. Standard practice when testing a trigger is to do an insert with single row values, multiple row values, single row select, multiple rows select. Corresponding, if we were testing an update or delete trigger, we'd do the same sort of thing, single as well as multiple row tests. Insert just a little different in that we can either do it via values or select. And again, don't get too excited about that syntax at this point. We'll get there and you'll know it by the time we're finished. Okay, good deal. Given that success with the customers table, let's move on to the customer addresses trigger and the before insert trigger on that table. Let's give that guy a test. All right, as you well know, the customer addresses table requires insertion of a valid address type. As such, the next few insert statements in your script just put a few rows into that table. So go ahead and execute those guys now and then do a commit. All right, let's start with a single row insert with values. Perfect, no problem. Hey, did you check our insertion of nulls into the country and state province fields? Remember, these 2 fields have a foreign key constraint on them too, but since they are nullable, we could sidestep that constraint by inserting nulls into those fields. Next, of course, we step it up a little with multiple inserts with values. Let's go ahead and add a work and other address type for the same customer. Perfect. Again, our trigger appears to be generating the appropriate address ID for each of these records. Our sequencer is working. As they say on ESPN, man, we must be butter because we're on a roll. All right, enough goofiness. Okay, next we move on to a single row insert with select. We start by validating our query generates only a single record. All right, our select statement seems to work fine. So let's go ahead and test it with an insert. Oh no! Our trigger's thrown an error indicating that it was not able to properly generate the next address ID. So what happened? Well, to find out, let's take that generic error message out of our trigger and recompile. Then we can rerun this insert and get a true Oracle-based error message. See what's really going on. Now we rerun our insert statement and see what Oracle is really complaining about. Oh no, the bane of every database designer's life. The infamous mutating trigger. There it is. But whatever shall we do, you ask? Well, unfortunately, the only real solution at this time is to drop this trigger because this bad boy simply isn't going to work this way. May as well drop the parallel trigger on order line items as well because we use the same logic there. It's not going to work either. Okay, once you've executed those two drop trigger commands, I would like you to delete all these records because we want to start out clean slate when we get to the next lecture. By the way, if you're messing around in other tables, please clean those up as well and make certain you do a commit. All right, here was the rule I gave you in the last lecture when we talked about mutating triggers. If at any time in that trigger you modify rows in the current table or modify rows in other tables which may in fact come back and modify the current table, the trigger is said to be mutating and Oracle will disallow the insert, update, or whatever trigger performance you're doing. Guys, doesn't work. It's a great idea, but they don't work once you get more complicated than simple. One value primary keys, it's just not going to work. It's unfortunate, but it's true. So why did we do these triggers in the first place? Why did we just not have you guys as programmers go to the database and find out what value is the current maximum address ID associated with a particular customer and then use that value? Well, it's the concept of round trips. That basically takes 2 round trips to the database to realize a single insertion, 1 to go get the next value and 2 to actually do the insertion. Now, if you're a single user on a local database, that doesn't mean a single thing. But if you're running a production database on 1,000 users, you just did a performance hit. Database designers think about performance hits every moment of every day. Similarly, to do it right, you as a programmer should actually put a lock on the customer addresses table when you do that first read, because you don't want anybody else coming in there until you've done your insert, or they'd be reading an invalid value as well. They potentially dupe up your next value calculation. Again, huge performance hit if you're dealing with a large number of users. It is what it is. We have to take balances in our designs all the time. We could, in fact, put these things into a package and do that and possibly make it a single round trip doing that. And that's probably what you'd have to do if you were building a big, credit card validation database or something like that. A simple online store, you don't have that many concurrent users, so go ahead and put the locks out there. It's just not that big a deal, but keep it in mind. As designers, it's what we have to think about every day. And by the way, that's what they pay us for. All right, that pretty much puts a wrap on our discussion of DDL, or data definition language. I hope you enjoyed, and I hope you learned something. All right, we'll see you in the next lecture and section wherein we're going to start data manipulation language. In fact, inserts, updates, and deletes should be great fun. In the interim, you know my routine. Go out there, have some fun. Remember, learn something every day.